In April 2008, there were demonstrations against rising food prices in many countries of the world. In Haiti, riots broke out, resulting in several deaths and many wounded. 80% of the population of Haiti at this time lived on less than $2 per day, so they were acutely sensitive to the price of basic foodstuffs such as rice, which had increased in price by over 50% in just a few months. Why did this happen?
This is actually a very complex question. One factor for sure were droughts in grain-producing nations, but also escalating fertilizer prices.
Then at the same time, we were seeing for the very first time the reaction to this hasty decision that was taken that the solution to global warming was to start producing fuel using through biofuels. And so the crops that would have been available to feed people became available instead to feed our automobiles.
It seems that many factors combined to cause the problems, including, according to some experts, attempts that were made to deal with other global problems such as climate change. But surely all of these aspects had been scientifically researched. What went wrong?
If we are going to solve the challenges we are facing with respect to all of the megatrends and the drivers changing the Earth, both from an economic point of view, environmental point of view, and social point of view, the systems analysis is a must.
It doesn't help you to know about a specific insect in a forest. You need to see a tree, you need to see dead trees, you need to see the pollinators, and you have to understand you need the energy fluxes, you need the fluxes of water, so you need the whole picture.
We need systems analysis, not just for modeling, but to also track change and also predict the future so that we could be ready and aware.
Global problems like climate change, population growth, water and food, and poverty are intrinsically interconnected. So only an interdisciplinary approach combining all the sciences, economics and policy can provide the models needed to find solutions. This is systems analysis. Research at YASA uses systems analysis to address some major issues.
A global energy assessment was initiated 6 years ago because humanity is facing many challenges and they can hardly be addressed without worrying about energy. We had, for example, a large international undertaking called Intergovernmental Panel on Climate Change that looked into the climate issues. So it's an equivalent process, trying to do an assessment. That means involving the latest knowledge, uncertainties about what we know about energy futures, and how we can respond to the challenges in the energy area.
We're trying to use science to help policymakers to make better decisions.
Just to give you an example, we have 7 billion people in the world today, 3 of whom still cook with solid fuels.
Like firewood, other forms of biomass, coal, charcoal, in very primitive stoves.
When housewives are cooking and they're inhaling these fumes, that's very deteriorating for health.
Leading to up to about 2 million premature deaths because of the indoor air pollution.
If they could replace this dirty biofuels with cleaner, so-called modern fuels, what we would achieve is of course a much lower level of exposure to hazardous substances in terms of air pollution. However, this may imply that these people would have to use fossil fuels. So that would actually lead to an increase in greenhouse gases. So there's a clear trade-off between two issues.
And therefore you have to have an integrated view to understand these and actually to make the policies coherent either from the climate science or climate side or then from the health side.
A lot of people are under the misconception that using biomass, because it's a renewable fuel, has no environmental impacts. This is not correct because there are huge greenhouse gas emissions like methane and nitrous oxide and aerosols like black carbon that we know have huge environmental impact.
Black carbon is emitted from incomplete combustion. So you emit soot to the atmosphere and then this migrates and eventually migrates to the Arctic area. And some of that is deposited on the snow. And so we have an influence of warming soot in the atmosphere, as well as warming soot or albedo changing soot in the deposited snow.
There may not be necessarily synergies so that you can solve both problems simultaneously. There may be trade-offs, but one needs to very carefully quantify these trade-offs and see, is it worth buying into these trade-offs for the greater benefit.
So, even changing a simple activity such as cooking on a stove has multiple consequences. Consequences that transcend national boundaries, and systems analysis helps to assess the countless scenarios if different policies are implemented. What about the solutions?
When you're talking about a single intervention like a cook stove requires changes in behavior, education, microcredit, perhaps fuel subsidies in some cases. There are a whole range of issues associated with even a single intervention.
What would be the alternatives? What would be the other options? Would they maybe more costly? Would they be less efficient?
The benefits, the ancillary benefits that we were talking about are humongous. I mean, there's time savings for the women. They don't have to go out and collect the fuel wood anymore, or they spend less time collecting it because they have more efficient stoves. That time can be used more productively either in income generation or education or even leisure, which these poor women have very little of.
The major finding of this long-term assessment is that we need a fundamental transformation in the way we do energy. We need an integrated approach trying to resolve all of the energy issues at the same time. One of the strong recommendations is that we have to try to find ways to resolve that during the next 20 years, and that will bring multiple benefits for development in general.
The challenges that the world faces are numerous. To eradicate poverty and starvation, provide modern forms of energy to all but avoid dangerous climate change, and all whilst demographics and populations change. Systems analysis is essential for developing policies that will help us tackle these challenges. With good independent research providing neutral solutions for issues that cross international boundaries, and with political will, millions of lives can be saved and quality of life transformed, and perhaps countries such as Haiti will never face starvation again.